Put. So the terminal side of an angle has this point. What is the sine? Isn't sine? Now remember, this only works if it's on the unit circle. You can't just assume sine is the y if you're given any old x, y point. But because it's a point on the unit circle, we can say sine is cosine's x, sine is y, so our answer is √3/2, right? Did you get it? Awesome. Now let's say I asked you, what's the tangent? You would do, does anyone remember? Yes, opposite, which would be y over x. Good. Yeah, so remember that tangent's your y value divided by your x value. So let's pretend like I said tangent. Then we would take √3/2, y divided by x, so -1/2. So dividing fractions is easy as pi plus a second and multiply. So the 2's would divide out. So my answer would be, if I asked you for the tangent, -√3. Does everybody see? Cool. All right, let's do another one. So create a cubic equation with some imaginary roots. Now you're going to have to remember, cubic is degree 3, correct? And then imaginary solutions, imaginary roots come in conjugate pairs. So how many imaginary roots could we have here? Could we have 4 imaginary roots? No, because that'd be degree 4, correct? Could we have 3 imaginary roots? Could we? No, right? Because they come in conjugate pairs. So there can't possibly be 3. Does that make sense, everybody? So how many imaginary solutions could this have at most? 2, and it has to have 2. There can't be 1 imaginary solution because they come in conjugate pairs. So create a cubic equation with some imaginary roots. Go. So yours is going to be different than your neighbor's. Hopefully, ready, set, go. Few people, there is a few. Like I saw Abby's on the right track. I saw a few others. Let's see. Lydia, I think you were on the right. Yep. Yes, almost on. Some of you are on the right track, and then some of you are on completely there, and then some of you are way off. So let's go. Let's talk about it. Everybody's answers could be different, but remember, this is what I'm saying people mess up on. They're saying x equals 2i. X equals, for example, that's an imaginary solution, right? That works, but then I'm seeing people do some random other one, like 3i. That won't work, because if 2i is a solution, what has to be a solution? -2i. Like I just said, imaginary solutions come in conjugate pairs. So if 3i is a solution, what has to be a solution? And all of a sudden, we have 4 roots. We can't have 4 roots, it's cubic. Because if you have 3i as a root, then -3i is a root. 1, 2, 3, 4. Imaginaries come in conjugate pairs. You can't have an I without a -i as a solution. Does that make sense? That would be fine, but then you couldn't have the 2i too. So we can only have pairs of 2, 4, 6, 8. Does that make sense? Of i's. So I'm going to even use one that's a little easier. 2i is great and -2i, as long as you use both. I'm going to just go with x equals I, x equals -i, just because those are really simple. Then what's another solution I could have? 2. Why not? Does everybody see how, because whole numbers or fractions do not have to have conjugate roots. But then I saw people starting to get there, but then they did this. Could I have, instead of 2, could I have done √2? No, because the rule also goes, if you have an irrational solution, it's conjugate. Now, irrational means can't be written as a fraction. Its conjugate also has to be a root. So do you see how this would be now a problem, everybody? So the only one I could do is a whole number or fraction. So I'm just going to go with the easy one, maybe x equals 1. And now you work backwards. So you would subtract it, make it equal to 0. So you have x minus I equals 0. X plus I equals 0, and x minus 1 equals 0, and then before they were split apart, they were multiplied together. So you have x minus I, x plus I, x minus 1. And then would it be smart for me to multiply together these two together first? Yes, because we always multiply conjugates together because middle terms cancel out and stuff, right? Okay, here we go. X times x is x squared. X times I, and anytime we're multiplying 3 things together, we multiply 2 together first, combine like terms, and then multiply in the third one. So then we have plus xi, or ix, minus ix, minus I squared. So then those cancel out. So we have x squared minus I squared. Can anyone tell me what that changes to be? Good, you're right. I squared equals -1. So we have x squared minus -1. So isn't that x squared plus 1, everybody? No one's confused? Okay, so then you would say, okay, I have x squared plus 1, and then my other one was x plus 1 or x minus 1, it doesn't matter. And then we would multiply out this, so x cubed plus x squared plus x plus 1. And now we've created a polynomial that has 3 roots where 2 are imaginary and 1 is real. All good? That reminds you of what we learned in the first unit of the year. Been a long time. Okay, awesome. So, ready, set, go. Try this one. Don't forget that. Those of you that are taking the stage, that last question, but they might say just create a cubic equation with all real roots. So you would use x equals 1, -1. You don't have to use 1 and -1 because you don't have to have conjugates, but you just use what's easiest. And x equals 3, for example. Okay, this one, state the end behavior. In calculus is what I called it, calculus notation. So if you need to draw yourself a rough picture and then state the end behavior. Okay, awesome. So it's an even degree. So what do we know about the end behavior? It's the same. Yep, it's the same. It's either up and up or down and down. Even degrees have end behavior that's the same. Now we look in front. It's negative. Negative people like to frown. So it's down and down. So I have a rough picture. It doesn't look like that. In fact, the middle does not look like that for this. This is a quadratic, but it's the end behavior is what we're looking at. So it doesn't matter what's happening in between here. This is what it looks like. So as x is approaching positive infinity, f of x is approaching negative infinity. As x is approaching negative infinity, our function's growing down to negative infinity. So everybody that's taking the stage, don't forget that, because you're going to be asked that. So if it would have been odd degree, let's say I made it 11, what would my end behavior be? Good. No, it'd be up and down because that's like a negative line. Does everybody see? Opposite end behavior, draw a negative line. So you just have to kind of think about it. It's a good review. Awesome. Okay, let's get going with what we're doing today. We're starting our statistics unit, which is a really interesting unit. A lot of people call statistics not even math, but it is for sure. But it's going to be really easy. We're going to just brush the surface of statistics. We're not even going to have to do much math. It's all adding and subtracting. If you want to just go on to get a degree in statistics, you could make a lot of money. I had a professor who was a statistician, made a lot of money. So, I mean, if you are interested in this as we go through it, you might want to think about going into statistics. Okay, so we're going to do even 2 lessons today in one. So we're going to kind of go through this really quickly. Everybody get out your graphing calculator, because I'm going to show you how to do a lot of stuff in your calculator. Okay, so people often refer to the mean as the average. So think if we have a bunch of points or a bunch of data, and we're looking at the center of the data, we can look at the center in many different ways. The most common ways of looking at the center of the data is the mean, median, mode, mean, median, and mode. So we'll get to that in just a second, but you can describe and compare sets of data using various statistical measures, depending on what characteristics you want to study. So that's what makes statistics hard. There's not one right answer. You're looking at data and you're making an inference, you're making a conclusion based on what you see from that. So statistics is the study, analysis, and interpretation of data. That's what's hard, is everybody's interpretation might be a little different. One way to analyze data is by finding the measures of central tendency. So if I say to you, find the measures of central tendency, that means look at the middle of the data, which we can look at. The most common are mean, median, and mode. And I'll remind you of what those things mean. So if I have these set of points up here, so look at these, 1, 2, 3, 3, 4, 5, 5, 9. Notice they're in order from least to greatest numerically. When comparing statistics and we're finding the measures of the central tendency, the middle, we need to have it ordered from least to greatest. So that's one thing to remember. So to find the mean, you sum up all of the data. So mean means average. So to find the average, you add up all those points and divide it by the number of points. So you sum them up, and then there's 8 points divided by 8. So our average is 4, everybody. How I remember what mean is when I say mean, I'm like, oh crap, what does that mean again? So if you said to me, oh, Miss Christensen, you're quite an average teacher, I'd say that's mean. I want you to say I'm a great teacher. If I said, oh, Joe, you're such an average student, that's not even nice. That's mean. So mean means average. If you call somebody average, that's a mean thing to say. So that helps me. It's a dumb little trick to help me remember. If I say find the mean, it means average. Median is literally the middle of the data. So literally smack dab, if you're counting the actual middle of the data, just like in the road, in the middle of the road, there's often medians that you don't want to drive over. It's right in the middle of the road. So to find the median, you literally count in and find the middle. So crossing out this and this on each side, this and this, this and this. Oh, crapola. It's between those two, correct? The middle? Yes?
Well, actually.
Okay, so because we would cross out these two, if to get to the middle, because we have to do it evenly, we would add those up and divide by 2 because it's right smack dab in the middle. Does everybody understand? A lot of times, though, you won't have to do that. It'll end on a middle point. So median means middle. Mode is what happens most frequently. So this one has 2 3s, 2 5s, so it's bimodal. That means there's 2 modes. So 3 and 5 would be our mode. Sometimes there's only 1 mode. You just say 3, for example, if there wasn't 2 5s. But then if there's more than 2 modes, statistically, it's not important. It's all affecting the data the same. So after 2 modes, you say no mode. Does that make sense? So if I added on a 9 here, you see how there'd be 3 modes? There'd be no mode. 2 modes is the most modes you can have. Awesome. Oh yeah, ask the question.
So for the median, if you're given like hundreds of variables, and you're trying to find the middle, is there more mathematics there? Like,
yeah, you could count. Well, yeah. So you could you could figure out the distance between. Like, that's kind of hard. You have to guess. There is a way. You just have to think about it pretty hard. I'm sure there's a way. And luckily, where we're just starting, it's just I'm sure there's a way. Let's pretend you were going to get your degree in stats. I'm sure they teach you how to do that. You know what I mean?
right.
But we're going to have just very basic. So that's a really good question. Okay, now we're going to get right into this new vocabulary word, and then I'm going to let you work for a second. So this word is called an outlier. So an outlier is a value that is substantially different from the rest of the data in the data set. So it's usually much, much larger or much, much smaller than the rest of the data in a data set. And what happens is, guys, think about it. If you have some value that's very clear out there compared to the other data values, isn't that going to affect your middle? That's going to affect your average. It's going to be way skewed. It's going to affect so many things. So an outlier sometimes makes your data seem like an outright liar. That's how it helps me remember. So I'm going to give you an example of how an outlier affects your measures of central tendency. So for example, let me show you this example. It's kind of interesting. So a teacher has to get an 80% average of her students' stage scores to keep her job. Let's say this is a true thing. So looking here, this person got a 75, a 90, a 99, and this person got a 20. Can anyone identify the outlier? 20. So outliers will be at the extremes, at either way lower or way higher. So they'll be at the edges. 20 is an outlier. But so let's see if this teacher gets to keep her job. Let's try and find the average. So hurry and add this up. 75 plus 90 plus 99 plus 20. Divided by 4. What's the average? 71. Okay. This teacher loses their job, but hopefully this teacher will then say, can I have my data so I can look at it? And the principal will say, yeah, because you have to give, if you're going to let a teacher go, you're going to have to give them why. He would say, well, you didn't get the average of 80. And she would say, okay, well, let me give you a little chit chat on statistics, principal. We have an outlier here. Now, Johnny is this person who scored this score. Johnny didn't come to school all year, and he was still required to take the stage score. He's the outlier. Do any of my other students score that low? No. So really, this is a fluke, and it's not my fault he didn't come to school all year. You should not count his score against me because that's bringing my measure of central tendency way down. Let's find the real average here. 75 plus 90 plus 99. Divided by 3. You got what? 88%. This teacher is a dang good teacher. You know what I mean? Like, really, that's a pretty dang good score. So that's how, for example, outliers can affect your measures of central tendency. Now, there's not one right answer. Maybe the principal says, you know what, I don't care that Johnny didn't come to school. I took the average of overall data. So there's not a right or wrong answer. There's technically, this isn't necessarily a better answer. It just depends on what you're looking at. Does that make sense? So then hopefully the other principal will have the sense to say, you know what, you're right. You should keep your job. And everybody see how it can affect it. Okay, awesome. So what I want you to do is you're actually going to just do 1 and 2 by hand. Then I'm going to show you in a second how to do the rest of those by the calculator. So do them by hand, 1 and 2, and then I'll show you how to do it by calculator. Ready, set, go. So make sure you order them in least to greatest. So pay attention, because the hard thing is if I ask you something knowing what I'm asking you for. So the range of a data set is the difference between the greatest and least values. Literally, range is what it means. What are these data values ranging over? So how much distance? So you would take to find your range, the total range, you would do the largest value minus the smallest value. So 12 minus, so our original range would be 12 minus 2 here, which is 10. So that means this is ranging over 10 values. Now here's the problem. Let's pretend I add in an outlier here. Let's say that I add in outlier, like let's say I add in 99, for example. Do you see how if I found the range overall at this point, then I would be saying this is ranging over 97 values. But really that's pretty skewed, because is it really ranging over 97 values? Not really. Like it's really only ranging over, you know, much less than that because of that outlier. I mean, yeah, technically it's ranging over 97, but the range as an 97 would maybe not be the range you want to use. So that's why they start talking about interquartile range. So that's a new vocabulary word. Interquartile range, and this is how they find it. So I'm going to erase the 99 and show you how to find interquartile range by hand. So what you do is you find the overall median, so the overall middle. So we go in evenly. So, oops. So in 1 in 1, and 1 in 1, and 1 in 1. Isn't the original median right between here? So you would do, right? That's how it works. So you would do 5 plus 8 divided by 2. Does everybody understand how to find the median? So isn't that 6.5? Okay. So our overall median is 6.5. Now, do you see how that splits it into 2 sections here? A lower section and an upper section. This is called the lower quadrant, and this is the upper quadrant. So the lower half of the data, the upper half of the data. Now what you're going to do is find the median of the lower half and the median of the upper half. So finding the median of the lower half going in evenly, our median of our lower half would be 3. Does everybody see? The median of our upper half would be 10. So now we can find the interquartile range by doing that median minus that median. So that would be a more accurate maybe median. A more accurate range. So to find the interquartile range, you're taking the middle of the data and only looking at the range there. That might be more accurate to describe range. Does everybody see why that might be useful? So 10 minus 3, so interquartile range, IQR, that's how we'll abbreviate it, is 10 minus 3, which is 7. Now this is also how we make a box and whisker plot. A box and whisker plot is this in just in a diagram. So let me show you how your diagram works for box and whisker plots. So for a box and whisker plot, you have your box and your whiskers. On your whiskers, this will come down to the minimum. The lower part of the whisker will be at your lowest value. The upper part of your whisker will be at your maximum. Now these are called, oh, I should go back real quick. So this is what's considered quartile 1. This is what's considered the median or quartile 2. And this is quartile 3, the median of the upper half. Does everybody understand? So the formula for interquartile range is Q3 minus Q1, which is what we did. Does everybody get it? Okay. So on your box and whisker plots, this is what we have here. We have our box. And then the middle line is your median, or Q2. The lower half of your box is Q1, and the upper half of your box where that ends is Q3. So if I drew a box and whisker plot of this, it would look like this. And I'm not going to draw it to scale because I'm not going to be that picky. I'm going to make a little box. I'm going to make a middle. So my middle is 6.5, right? The lower half of the box is Q1, so 3. The upper half of the box is Q3, which is 10. I would do my little whisker. This will be 12, because that's my highest point, and my other whisker would be 2. So notice I didn't drop to scale, right? Because this is 2 units, this is only 1 unit, but whatever. Everybody see how this works? Okay, cool. Now I'll show you how to do it in your calculator. So let's go ahead and pull up our calculators. You'll have to remember this for your ACTs and stuff, because this is going to make your life so easy. It's going to literally give you all that information by calculator. So everybody follow me through this. Number 7. So we're going to make a box and whisker plot for number 7. And we'll list out the meat, all that information. So what you're going to do is, this is statistics, so you're going to go into the stat key, into edit. So follow me through, because it's always the calculator that gets people. In list 1, type in all of those values. Now remember, if you already have stuff, you need to go up here. Do not hit delete, or else you're in big trouble and you have to restart your calculator. Hit clear, and then scroll down. I'm not going to do it because I don't want to retype mine in. So if you go up here and hit clear, and then scroll down, it will clear out all the values for you. You shouldn't have anything typed in list 2 or list 3, just list 1. So ready, go. Number 7, type in those values. These are average temperatures in January for several cities in the Mid-South. So we're going to be able to look at the median temperature in the South, the average, the mode, what happens most, and whatnot. All of those values. I mean, all of our values, whatever we're looking at. So we're doing number 7. So you'll type in those values. Okay, so now what you're going to do is hit the stat key again, stat. Now instead of edit, we're going to go over to calculate. We're just dealing with single variables, meaning we're just looking at one thing here. So we're going to do the one variable stats. So number 1, hit enter. Hit enter. So X bar is another way of stating, and if you ever see X bar, that means median, the average. No, sorry. The average, which is the mean. Sorry. Mean is average. X bar is average. So look, it found the average for us. X bar is average. Everybody good? Now you have to ignore all this stuff for a second. We're going to talk about this in a minute. The sum, this means the sum. You remember how we just did sums? This is saying the sum of all of them, which we don't care about, but just so you know what this is. This is the sum squared. And then this is standard deviation. We're going to use it in a minute. N equals 12. That means there was 12 values we put in. Now look, scroll down so you don't have to do this by hand. You don't have to add them up and divide by 12 by hand because it did it for you. So now scroll down. Look, there's your min value. Your lowest temperature is 39.9. Q1, so that would be the top of your box. Our median, which would be the middle line in our box. Q3, which would be our top line in our box, the end of our box, and then our max is given. So we can draw our box and whisker plot given this. And then if I say to you, find the interquartile range, all you have to do is Q3 minus Q1, 50.8 minus 44.3. Everybody good? If I say find the range, you would do the max minus the min, because that would be the overall range versus interquartile range. So, can you guys finish now the front page here? Yes? Are we good? Can you draw a box and whisker plot? Okay. So, you're going to do, we'll come back to percentile. So what I want you to do is right now, work on the front page. Make yeah. And you'll just type them into your calculator. And then you go finish the front page, because now notice it didn't give you the mode. So you're going to have to just look with your eyeballs and figure out the mode, which happens most. You're given super easy. Like look at number 3. What would our mode be? 17, because it happened 9 times. Okay, ready, set, go. Finish the front page. But people get confused on what it means. So now we're going to learn the vocabulary word percentile and how to find percentile. So a percentile is literally a percent. Makes sense, right? So it says a percentile is a number from 0 to 100, which makes sense. Aren't percents either 0% up to 100%? So it says a percentile is a number from 0 to 100 that you can associate with a value x from a data set. So for example, it says, it shows that the percent of the data that are less than or equal to x. So for example, if x is at the 63rd percentile, then 63% of the data are at that or below that value. So let me give you a better example. If we just took a test, everybody, and I'm not even talking about your scores, but I tell you, Elijah scored within the 90th percentile. What that means is 90% of you scored below him or at him. Does that make sense? So he'd be up there high. Only very few of you scored above him, right? 10% of you. Does that make sense, everybody? So to find percent, remember, you need to know the total divided by the number you're at. So, for example, right here, this is a perfect example of that. So here are scores of a Spanish class on a test, for example. So notice, to find a percentile, this is very important. You have to have your values in order from least to greatest. Now, when we're talking percentile, you don't use these values to find the percent. It has nothing to do with these. Does everybody understand that? I want to know, for example, what's at the 65th percentile. That means what score is going to be at the 65th percentile, meaning that 65% of these scores will be at that score or below that score. So to know the 65th percentile, I need to know the total number of students or the total number of scores. So let's count it up. There's 20 students here. So out of 20 students, what's the 63rd percentile? So that means what is at that value or below that. So you take 20 times 0.63. How many values in do I need to go? Oh, yeah, it was 65%. Good question. Good point. So you type in 20 times 0.65 to find 65% of 20. 13 scores. So I need to go in 13 scores. Does that make sense, everybody? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 82, the score of 82 is at the 65th percentile. 65% of the data is at 82 or below 82. Does everybody see how that works? So if I said to you, let's go the other way. Let's go the other way. If I said to you, what percentile is score 77 at? Well, we need to count how many in that is, correct? Out of 20. So we would go to the furthest. Notice that's the mode, correct? But we would have to count, this is at that value or below that. So we'll go to the furthest one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 20. So without a calculator, what's the percentile that's at? 50. Does everybody see how to go backwards? If I said to you, what percentile is 77 at? You'd say the 50th percentile. That means 50% of the data is at 77 or below 77. All good? You don't need another example of percentile. That's all the same thing. So if I said to you, what's at the 90th percentile? You would take 20 students times 0.90. How many in do I need to go? 18. Make sure you type in 0.90. You'd need to go in 18. So 98 would be at the 90th percentile. Everybody good? 90% of the students scored at that or below that. Okay. Cool. So I just want to tell you where this is actually used. So if you took an SAT score, so in Utah, we take ACT instead of SAT, but there are some colleges that some of you might be considering going to outside of Utah where they require you to take the SAT. When you take the SAT, they will give you a percentile, because think about it, guys. Let's say that you take the SAT and they tell you you got a 67 out of 90. Literally, if you just go off of that, what good is it? Because really, well, what does that mean? Without a percentile, you don't know what that means because you don't know how well most people do. Does that make sense? Like, so by looks of it, let's say if you were just going off of that, if you got 67 out of 90, what percent technically did you get? 67 out of 90. 67 divided by 90 is what percent? 74%. So you might be thinking, well, I didn't do that good. But then they say to you, but you scored within the 90th percentile. So you know that score, 67 out of 90, was dang good. Because 90% of students scored at that score or below that score. So do you see how it doesn't really have meaning until you know what percentile you're scored at? Everybody? Because if you got 67 out of 90 and you're in, well, that looks like not that good of a score. But if I say, but you were in the 90th percentile, you can say, yeah, I did dang good. Okay, everybody understand? Yeah. Okay, awesome. So it says percentiles are commonly used to report scores in tests like SAT, GRE, or LSTAT. For example, so the law pre-entrance law exam. So for example, the 70th percentile on a 2013 GRE was 156. So you know, okay, I got this score, so I scored within the 70th percentile, so 70% of students scored at me or below me, which isn't bad, but not the best either. So that's how it is. It's really cool. Anyways, okay. So I don't need to give you any more time. Finish 12-1, ready, set, go.